All right, in case you missed it today, here's the intro video on complex numbers. The objectives today is to solve quadratic equations with complex solutions. And really today we're focusing on just simplifying expressions that involve complex numbers. So first of all, what is a complex number? Complex numbers are numbers that include imaginary units and imaginary numbers. So welcome to Algebra 2, where you're introduced to imaginary numbers. Imaginary numbers are defined as the square root of negative numbers. And I is what we use to represent an imaginary number, and I equals the square root of negative 1. And since I equals the square root of negative 1, that means I squared is equal to negative 1. I can be used to find the square root of any negative number. For example, the square root of negative 16, since the square root of positive 16 equals 4, the square root of negative 16 equals 4i. So got the square root of 16 is 4, and the square root of negative 1, now my pen's not working, so that's great, is I. All right. If you have a square root of a number like 5 where it's irrational, it can be written like this. The square root of negative 5 is the same thing as I square roots of 5. We leave it like this so it's in the exact form, since the square root of 5 would be a non-repeating decimal. Oops, I don't want that up either. Okay, so complex numbers are numbers that are written as you have a real part and an imaginary part. We let A be the real part and BI is the imaginary part. So inside our whole number realm, you have real numbers here. Those are the numbers you've been working with forever, like 3, negative 1, square root of 2, pi. Then you have your imaginary numbers. Imaginary numbers are the negative 4i, the square root of negative 1, square root of negative 5. And then you have the complex numbers that include both the real and the imaginary part. So just identifying the real and imaginary part of complex numbers. Here, the 2 is the real part, and the 4i is the imaginary part. If you have a 1/2, 1/2 is just a real number. There is no imaginary part. If you have negative 5i plus 2, to write that in standard form, it'd really be 2 minus 5i, where 2 is the real part and 5 is the imaginary part. You just have 6i. Really have no real parts, it's just a pure imaginary part. So no real parts, just pure imaginary. All right, and today we're going to focus on just working with imaginary numbers. So we're going to skip that side for now because we really haven't talked about solving with square roots yet. So we're going to write an expression as a complex number in standard form. And standard form means we want the real part to come first, then we're going to add the imaginary part to the end. So we want it to be a plus bi. And just like when we add binomials or any expressions, we add like terms. So here's just a plus 3 plus 3i, so there's nothing to distribute in front of this parenthesis, so we can just go ahead and combine like terms. Negative 1 plus 3 is 2, and then 2i plus 3i is 5i, just like 2x plus 3x is 5x. And we're done there. When we subtract, we have to be a little bit more careful. So you have 2 minus 3i, and then you have minus 3 minus 7i. So you have to subtract both of these. So really you have to distribute that subtraction sign through here. So minus and negative 7i would really be a plus of 7i. Then combine like terms, we want to put the real part first. So 2 minus 3 is negative 1. And negative 3i plus 7i is 4i. Okay, here we have a subtraction, so you have to distribute that minus sign through this one. So it'll be 2i minus 3 minus I, and then plus plus 2 and plus negative 3i. Then combine like terms. I want the real part to come first again, so I got a negative 3 and a positive 2 is a negative 1. Then I have three imaginary parts, a negative 2, a negative 1, and negative 3. I'm sorry, that's a positive 2. Positive 2i minus 3i. So that'll be 2i minus 4i, which will be negative 2i. I want to write the real part first, followed by the imaginary. So multiplying an expression by an imaginary part. So negative I times 3 plus I. So we can use the distributive property with negative numbers as well, or not negative numbers, imaginary numbers. So just like when you distribute, you're going to distribute this I through. You're going to get 3 times negative I will be negative 3i. And then negative I times I will be negative I squared. Then we have to remember that since I equals the square root of negative 1, that I squared equals negative 1. So here you really have negative 3i minus negative 1. And negative 3i minus negative 1 is negative 3i plus 1. And we want to write that in standard form, so it'll be 1 first minus 3i. Let's do another one here. 2i times 4 is 8i. Just multiply the 2 by the 4 and the I follows along. And then 2 times negative I, it's like 2 times negative 1 is negative 2, and I times I is I squared. Then we go back to I squared equals negative 1, so we'll have to replace that I squared. We'll substitute in negative 1. Then 2 times negative 1 is positive 2, so you got 8i plus 2. And we want to write that in standard form, which means it's 2 plus 8i. Final answer there. And last example, negative 3 times 6 will be negative 18i. And negative 3 times 5. So negative 3 times 5 is negative 15. And I times I is I squared. Again, I squared equals negative 1. So we'll rewrite that with substituting negative 1 in for I squared. Then negative 15 times negative 1 is positive 15. I want that to go out front, minus 18i. So we have the real part of that is 18, and we have an imaginary part of, the real part is 15, the imaginary part is negative 18i. And that's all. So let me know how it goes.